Hey, welcome back. My name is Sushant Satish, and I am your trainer for this Azure Administrator Associate AZ-104 certification course. We are starting a brand new module in this video. The new module is called Azure Virtual Machine. And the first lesson we are going to learn in this video, it's all about virtual machine planning. Let's have a look at the things we are going to learn in this video. We will start with what is infrastructure as a cloud, what are the components involved in infrastructure as a cloud, and what are the scenarios. Then before you select placing a workload in Azure, what are the planning checklists you need to keep in mind? And when it comes to where to place these workloads, what about the location and the pricing of these workloads? Before you selecting a virtual machine, you need to understand the different types of sizes and the families available within virtual machine. And how about these virtual machine disks, both for data and the operating system? And what are the other storage options available for a virtual machine? And we will touch base on the supported operating system and the virtual machine connections. When I explain about these concepts, I will take you back and forth the Azure portal so that it makes total sense to you what I am trying to convey. So without wasting any more time, let's get into it. Azure Virtual Machine is one of the several types of on-demand, scalable computing resources that Azure offers. Typically, you will choose a virtual machine if you need more control over your computing environment than the choices such as app service or cloud services offer. Azure Virtual Machines provide you with operating system, storage, and networking capabilities and can run a wide range of applications. Virtual machines are part of the infrastructure as a service or IaaS offering. IaaS is an instant cloud infrastructure provisioned and managed over the internet. You can quickly scale up and down with the demand and pay only for what you use. There are so many business scenarios where IaaS perfectly makes sense. So let me tell you each one by one. The first scenario which I can think of is test and development. Teams can quickly set up and dismantle test and development environments, bringing new application to market faster. IaaS make it quick and economical to scale up dev test environment up and down. Another business scenario is for website hosting. Running website using IaaS can be less expensive than traditional web hosting. What about storage, backup, and recovery? Another scenario where you can leverage IaaS is for storage, backup, and recovery. Organizations avoid the capital outlay for storage and complexity of storage management, which typically requires a skilled staff to manage data and meet legal and compliance requirements. IaaS is useful for handling unpredictable demand and steadily growing storage needs. It can also simplify planning and management of backup and recovery systems. Another business scenario is about high-performance computing. High-performance computing on supercomputers, computer grids, or computer cluster helps solve complex problems involving millions of variables or calculations. Examples include earthquake or protein folding simulations, climate and weather predictions, financial modeling, and evaluating product designs. Another business scenario is big data analysis. Big data is a popular term for massive data sets that contain potentially valuable patterns, trends, and associations. Mining data sets to locate or tease out these hidden patterns requires a huge amount of processing power, which IaaS economically provides. Last but not the least is extended data center. You can add extra capacity to your data center by adding virtual machines in Azure instead of inquiring the cost of physically adding hardware or space to your physical location. You can connect your physical network to Azure cloud network seamlessly. Alright, so before provisioning a VM to Azure, which requires so much. So before you start provisioning VMs in Azure, you need some sort of a planning. Before you create a single VM, make sure you have thought about network, naming the VM, deciding the location of the VM, how to determine the size of the VM, understanding the different pricing model, storage of the VM, and selecting the VMs, etc. Let's look at the first planning, which is all about starting with the network. Virtual networks or VNets are used in Azure to provide private connectivity between Azure Virtual Machine and Azure services. VMs and services that are part of same virtual network can access one another. By default, services outside the virtual network cannot connect to the services within the virtual network. You can, however, configure the network to allow access to the external service, including your on-premises servers. One another planning we need to make sure is that to name our VMs correctly. One piece of information people often don't put much thought into is the name of the VM. The VM name is used as the computer name, which is configured as part of the operating system. You can specify a name of up to 15 characters on a Windows VM and 64 characters on a Linux VM. The name also defines a manageable Azure resource, and it's not trivial to change later. This means that you should choose the names that are meaningful and consistent, so you can easily identify what the VM does. A good convention is to include the following information names. Something which has the VM should include things like environment, like a dev, prod, or QA or test, location where the VM belongs, the instance count, and what sort of a product it is, and the type of roles which you have installed on that VM. Another type of planning is to decide the location of the VM. Azure has data centers all over the world filled with servers and disks. These data centers are grouped into geographic regions. Example, West US, North Europe, Southeast Asia, etc. to provide redundancy and availability. When you create and deploy a virtual machine, you must select a region where you want these resources. This lets you place your VMs as close as possible to your users to improve performance and to meet any legal compliance or tax requirements. Two other things to think about regarding the location choice are the location can limit your available options because each region has different hardware available and some configurations are not available in all regions. Another thing to keep in mind is there are price differences between these locations. So if your workload isn't bound to a specific location, it can be very cost effective to check your required configuration in multiple regions to find the lowest price. Another thing to consider while planning for a virtual machine is know the pricing options. There are two separate costs the subscription will be charged for every VM, compute and storage. By separating these costs, you scale them independently and only pay for what you need. Let's talk about the compute cost. The compute expenses are priced on per hour basis and billed on per minute basis. For example, you are only charged for 55 minutes of usage if the VM is deployed for 55 minutes. You're not charged for compute capacity if you stop and deallocate the VM since this is released the hardware. So if you deallocate the compute, you are not being charged for the compute capacity. The hourly price varies between the VM sizes and the operating system you select. The cost of the VM include the charge of the Windows operating system And Linux-based instances are cheaper because there is no operating system license charge. Let's understand the storage cost. You are charged separately for the storage the VM uses. The status of the VM has no relation to the storage changes that will be inquired. Even if the VM is stopped, deallocated, and you aren't billed for the running VM, you will be charged for the storage used by the disk. For the compute cost, there are two payment options. One is pay as you go, another one is reserved virtual machine instances. With the consumption based option, you pay for the compute capacity by the second, and you are able to increase or decrease compute capacity on demand as well as start or stop at any time. The reserved virtual machine option is an advanced purchase of a virtual machine for 1 or 3 years in a specified region. This commitment is made upfront, and in return, you get up to 72% price savings compared to the pay-as-you-go pricing. And these reserved instances are flexible and can easily be exchanged or returned for an early termination fee. You can prefer this option if the VM has to run continuously, or you need to budget predictability, and you can commit to using this VM for at least a year. Let's understand the next planning method. It's all about virtual machine sizing. Once you have the name and the location set, you need to decide on the size of your virtual machine. Rather than specify processing power, memory, storage capacity independently, Azure provides different VM sizes that offers variations of these elements in different sizes. And Azure provides a wide range of VM size options, allowing you to select the appropriate mix of compute, memory, and storage for what you want to do. So the best way to determine the appropriate VM size is to consider the type of workload your VM needs to run. Based on the workload, you would be able to choose from a subset of available VM sizes. Some of the workloads are classified as general purpose, compute optimized, memory optimized, storage optimized, GPU, and high performance compute. And you can find different family sizes for each of these different types of VM type. And if you're wondering how to resize your virtual machine, so let me show you how you can resize a virtual machine. I am in my Azure portal, selecting an existing virtual machine. Under settings, you can find size. Within size, as you notice, if my VM is on B2MS, I can go back to size and select any other size which is available over here. If I want more option, I can click on See More Sizes and select a VM which I would like to resize this VM to, and click on this resize option. Azure allows you to change the VM size when the existing size no longer meets your need. You can resize the VM as long as your current hardware configuration is allowed in the new size. This provides a fully agile and elastic approach to the VM management. If you stop and deallocate the VM, you can then select any size available in your region. Please note that be cautious when resizing production VMs. They may need to be rebooted, which can cause a temporary outage and change some configuration settings such as the IP address. Another planning we need to consider in our mind is about virtual machine disk. Every virtual machine has one attached operating system disk. The OS disk has a pre-installed OS which was selected when the VM was created. The disk has the maximum capacity of 2 terabytes. It's registered as a SATA disk and labeled as C drive by default. And every VM contains a temporary disk as well, which is not a managed disk. So let's understand what is temporary disk. The temporary disk provides short-term storage for applications and processes and is intended to only store data such as a page or swap files. Data on the temporary disk may be lost during a maintenance event or when you redeploy a VM. During a standard reboot of the VM, the data on the temporary disk should persist. However, there are cases where the data may not persist, such as moving to a new host. Therefore, any data on the temp drive should not be the data that is critical to the system. Then there is data disk. A data disk is a managed disk that is attached to the virtual machine to store application data or other data you need to keep. Data disks are registered as SCSI drives and are labeled with the letter that you choose. Each data disk has a maximum capacity of 4 terabytes. The size of the virtual machine determines how many data disks you can attach to it and the type of storage you can use to host the disk. Let's understand the Azure Virtual Machine storage options. Azure Premium Storage delivers high performance, low latency disk support for virtual machines with I/O intensive workloads. The VM disks that use premium storage store data on a solid state drive, which is SSDs. To take advantage of the speed and performance of the premium storage disk, you can migrate existing disks to a premium storage. In Azure, you can attach several premium storage disks to a VM using multiple disks, gives your application up to 256 terabytes of storage per VM. With premium storage, your application can achieve up to 80,000 I/O operations per second per VM and a disk throughput of up to 2,000 megabytes per second per VM. Even though managed disks are the only one which is supported, let's talk about what is unmanaged disk. The original method is to use unmanaged disk. In an unmanaged disk, you can manage the storage account that you use to store the virtual disk, files that compressed of your VM disk. VHD files are stored as page blob in the Azure storage account. So now you don't have to worry about it. Just learn about what is managed disk. An Azure managed disk is a virtual hard drive. You can think of it's like a physical disk in an on-premises server, but virtualized. An Azure managed disk are stored as page blobs, which are a random I/O storage object in Azure. We call a managed disk managed because it is an abstraction over page blobs, blob containers, and Azure storage accounts. With managed disk, all you have to do is provision the disk and Azure takes care of the rest. For the best performance for your application, we recommend that you migrate any VM disk that requires high IOPS to premium storage. And please note that managed disks are required for a single instance virtual machine SLA of 99.95%. Let's talk about the supported operating system. Azure provides a variety of operating system images that you can install into your VMs. So let me show you what are the operating system available on a high level. I'm going to create a new virtual machine. And if I scroll down to images, this is where you can see all the available operating systems and you can browse for all public and private images here. This is including several versions of Windows and flavors of Linux. If you are looking for more than just base operating system, you can search the Azure Marketplace. For more sophisticated install images that include the OS and popular software tools installed for specific scenarios. For example, if you need to choose a new WordPress site, the standard technology stack would consist of a Linux server, Apache Word Server, a MySQL database, and PHP. Instead of setting up and configuring each component, you can leverage a marketplace image and install the entire stack at once. Finally, if you can't find a suitable operating system image, you can create your disk image with what you need and upload it to Azure Storage and use it to create an Azure VM. Please keep in mind that Azure only supports 64-bit operating systems. So before we move on, let's understand the Windows Server Software Licensing and Linux Server Software Licensing model. All Microsoft software that's included in the Azure Virtual Machine environment must be licensed correctly. By default, virtual machines include a license for many common products, including Microsoft Server, Microsoft Exchange, SQL Server, SharePoint Server, etc. Certain virtual machine offering may include additional Microsoft software on a per hour or evaluation basis. And licenses for other softwares must be obtained separately. Please note that Microsoft do not support an upgrade of Windows operating system of a Microsoft Azure virtual machine. Instead, you should create a new virtual machine that is running the supported version of the operating system that is required and then migrate the workload. And Azure supports many Linux distributions and versions including CentOS by OpenLogic, CoreOS, Debian, Oracle Linux, Red Hat Enterprise Linux, and Ubuntu. Please note that Linux endorsed distribution support and upgrade of the operating system of a Microsoft Azure virtual machine in case of a full open source license. If license specific distribution is used, then follow partner specific rules to upgrade, bring your own license or other. And let's understand the virtual machine connections. There are several ways to access virtual machine in Azure. For a Windows-based virtual machine, you will use the remote desktop client to connect to the Windows-based VM host on Azure. Most versions of Windows natively contain support for the RDP. To connect to a Linux-based VM, you need a Secure Shell Protocol SSH client. For example, PuTTY, which is a free and open source terminal emulator, Serial Console, and network file share application. PuTTY supports several network protocols including SCP, SSH, Telnet, rlogon, and raw socket connection. It can also connect to a serial port. Please note that how to connect to RDP and SSH will be covered more in detail in the coming videos. Another way of connecting to Azure machines using Bastion connections. The Azure Bastion service is a new, fully platform managed PaaS service that you provision inside your virtual network. Once you go inside a virtual machine, under operations, you can find Bastion there. And Bastion provides secure and seamless RDP or SSH connectivity to your virtual machines directly in the Azure portal over SSL. When you connect via Azure Bastion, your virtual machine do not need a public IP address. And Bastion provides secure RDP and SSH connectivity to all VMs in the virtual network. Using Azure Bastion protects your virtual machine from exposing RDP or SSH port to the outside world while still providing secure access using RDP and SSH. With Azure Bastion, you connect to virtual machine directly from your Azure portal. You don't need an additional client, agent, or a piece of software. So that concludes the first lesson of the module 8, which is all about Azure Virtual Machine. In the next video, we're going to talk about how to create a virtual machine. So I will see you on the next one. Till then, take care.